or y prime, it doesn't matter. Okay, bring down the power, subtract 1 from the power, right? 3/2 minus 1 is 1/2. Bring down the power, multiply by 4, get a 2. Subtract 1 from the power, x to negative 1/2. Bring down the negative 1/2, negative 3/2 now. Subtract 1 from the power, x to negative 3/2. As I said, there is nothing really very easy. Okay, and here is a question similar to what you asked earlier. Let's say, okay, I found an easier one. So y equals x to the 4th plus 2x squared minus x at the point 1, 2. So they want, find the equation of the tangent line to the curve at the given point. Now, of course, this will not be easy. It is not difficult, but it's long to use the definition. But we can find y prime in a blink. 4x to the 3rd plus 6x minus 1. It's done. I will plug in 1. So y prime when x is 1. This is the way we write it. Y prime when x is 1. Or you can say, I don't want this. I want f prime of 1. Same thing. You plug in 1. 10 minus 1 is 9. So now y minus 2 equals 9 times x minus 1. I distribute 9x minus 9, but plus 2. So minus 7. So 9x minus 9, but I have to add 2. Minus 9 or negative 9 plus 2 will be negative 7. Done.
Excuse me, Professor?
Anytime, yes.
Would it be, I don't know, how would you say it? When you put y equals x.
Oh, yeah. I'm sorry.
Okay, thank you.
I don't know why I multiplied by 3 instead of, sorry. Thank you so much. My apologies to all of you. So what was 8 minus 1, 7. Thank you very much. So we have negative 7. Negative 7 plus 2 is negative 5. Sorry. Of course. So 4x to the 3rd, 4x, subtract 1 from the power, and the derivative of negative x is negative 1. So when I plug in 8 minus 1 is 7. So I have 7x. I'm checking now everything. So minus 7 and plus 2, negative 5. Thank you so much. I wasn't trying to check whether you were asleep or not. No, I was asleep. Okay. Okay, I want to look at one more problem, and then we can move on. So the equation of motion of a particle is s of t equals t to the 4th minus 2t cubed plus t squared minus t. S is in meters. T is in seconds. Find the velocity and acceleration as functions of t. So part A, find the velocity, and then also part A, find the acceleration. So if this is the distance formula, how will I find the velocity? What is the velocity? Is the rate of change of distance with respect to time. So how do I find the rate of change of this function? What do I need to do?
Take the derivative?
Correct. So this is s prime of t. So what do I get? Can anyone try this?
It's 4t to the 3rd power minus 6t squared plus 2t minus 1.
Brilliant. What is the acceleration for the velocity? is the first derivative of the velocity. And what is the acceleration for the distance? Is the second derivative of the distance. Can anyone give it a try here?
Uh, 12t squared minus 12t plus 2.
That's it. Part B. Any questions?
So when it says take the second derivative, you just take the derivative you already found and then take the derivative of that.
Exactly. Is the rate of change of this one. Perfect.
What exactly did we just do? You kind of lost me there.
That's okay. So you mean from here?
Yes.
Okay. So when we apply the power rule on t to the fourth, we have to bring 4 down and subtract 1 from the power. Is that okay?
Where's the V and the A and then the 2 dashes next to the S? I get V is
So v is the velocity,
velocity.
function of time, which is the first derivative of the distance. So we are differentiating this. So 4 in front, subtract 1 from the power. Is this okay?
Yes.
Then we bring 3 down, we multiply, we get -6, and subtract 1 from the power.
Yes.
We bring 2 down, and we subtract 1 from the power.
Yes.
And then a long time ago today, we established that the derivative of this is -1.
Is it 1 or -1?
If there is minus in front, I have to write -1. If it's positive in front, I have to write 1.
Yeah, I get that. If it's 1, it will be negative. I just
That's okay.
when you said it would be -1, I thought you were talking about
Because
solely
it's
the
negative
variable,
t.
not the negative.
So when every quantity is taken with a sign in front. So this one has plus, it goes with plus. This one has -2, it goes with -2. So the derivative of -t is -1. So now we repeated the process. We brought 3 down.
Just to double check,
Yes.
the derivative of a constant is 0, which is why we didn't bring down anything for -1.
You mean from here?
On the second derivative. Yeah.
Yes, we established that the derivative of any constant is 0. Okay. So we brought 3 down, we got 12, subtracted 1 from the power. We brought 2 down, we got -12, subtracted 1 from the power. And the derivative of 2t, because the derivative of t is 1, the derivative of 2t is 2. Is that better?
Yes.
Perfect. So now in part B, they're asking us to find the velocity. No, the acceleration at 1 second. So all I have to do is a of 1. So 12 minus 12, this will be 0 when t is 1. So this is 2. Can anyone give us the measurement unit for the acceleration? Is the rate of change of velocity with respect to time?
Meters. Would it be meters per second?
But that's the velocity. Distance with respect to time will be meters per second, but this is the rate of change of a velocity with respect to time. Okay, let's talk about this, and then I'll come back. So any rate of change has 2 measurement units. So if it's velocity, it's in meters, rate of change of distance for this problem, with respect to time, which is seconds. But if we are talking about the rate of change of velocity, which is the acceleration, we have to have this, the rate of change of velocity, with respect to time. So velocity is rate of change of distance with respect to time. Acceleration is the rate of change of velocity with respect to time. So velocity is measured in meters per second, but the acceleration cannot be measured in meters per second. because that's the, yes?
I'm sorry, would it be meters per second squared?
Perfect. That's what it is. So please don't confuse velocity with acceleration. Velocity is the rate of change of distance with respect to time. Acceleration is the rate of change of velocity with respect to time. Any questions here? Okay. Product and quotient rules. Before that, I want to give you a theorem that is in chapter 4, but I never wait till chapter 4 because it's too important. And it will help you with limits. And you can check with this, but you cannot really use it just for Thursday. It's called Lopital. Lopital's rule. That was his name. He said this, that only in the situation of 0 over 0 or infinity over infinity, so these are indeterminate cases, only in these two situations, if I have a limit of a polynomial or an expression over another expression as x approaches a, and initially I have 0 over 0 or infinity over infinity, then it's okay to do this. Limit as x approaches a from p prime of x over q prime of x, and find the limit. So here's an example. Let's say we have limit as x approaches 3 from x minus 3 squared over x squared minus 4x plus 3. Am I okay? 9 plus 3, yes. Okay. You could say, well, when you plug in 3, you get 0 over 0. This is a simple situation. Obviously, I can factor the denominator, and you could. X minus 3 squared. Can anyone give us the factor form in the denominator?
X minus 3, x minus 4.
Very good. X minus 1, x minus 3, good. And of course, the problem will go away. Now you plug in 3, and it happens that you get 0, because the numerator is 0, but the denominator is 3 minus 1, which is 2. 0 over 2 is 0. But this is what we've been doing so far. But let me give you the same, let's work on the same problem in a different way, like with Lopital's rule. So limit as x approaches 3. I will expand that. X squared minus 6x plus 9 over x squared minus 4x plus 3. And I get the same thing, 0 over 0. Let's say I don't notice that these are factorable and I don't even want to use that method. What I'm going to do, I'm going to write limit as x approaches 3 because first of all, it's a fraction. Secondly, I have 0 over 0. I can differentiate the top by itself and the bottom by itself. So what do I get when I differentiate the numerator?
So it's 2x minus 6.
Perfect. And what about the denominator?
No, the denominator is 2x minus 4.
Good.
But so you have to split it up like that in order to take the derivative of it?
Because we don't know the chain rule yet. You don't have to. But I can't explain the chain rule right now. I will in the next section. But right now, that's why I had to distribute. Yeah. Good. So now let's plug in again. So what is the numerator? where does the numerator go?
0.
Excellent. Where does the denominator go?
2.
Excellent. And the answer? I have $0 that I would love to share with 2 of you.
0.
Absolutely. So this is a different way, and this is a very elegant way. However, it's limited to these 2 possibilities. So keep that in mind. We're going to use it a lot. So now we're going to look at the product and the quotient rules. Okay. So if we have a function divided by another function, so one more time, we will never differentiate a quotient like this, ever. I'm allowed to in a limit. If the limit is not here, I could never say that P of X or over Q of X or P over Q prime is P prime over Q prime. This is allowed only inside the limit. If I don't have the limit, I cannot apply this procedure, ever. Okay. So when we have a quotient or when we have a product of 2 functions and we want to differentiate, these are specific rules that we have to memorize. I present them in a certain way. If you prefer a different way, I'm fine with that. I present this as function 1 and function 2. So I use that sequence. So fg prime, a product of 2 functions, is f prime times g plus f times g prime. And this is carved in stone, meaning every time I have a product like e to the x times x to the 4th, for example, this is function 1, function 2, function 1, function 2, function 1, function 2. The first time this is prime, the second time this is prime. How do I differentiate? First, the first function. What is e to the x prime equal to?
E to the x.
Perfect. Then I have to copy the second function. Then I reached plus. Then I have to copy the first function. And now I'm differentiating the second one. Can anyone give us the derivative of the second function?
4x cubed.
4x cubed. And yes, I will factor out e to the x and x to the 3rd, and I have x plus 4. This is crucial for what follows after this chapter. So this is the product rule. Product rule. Your book likes to twist this. Fine. You can twist this if you want. You can twist this. You can twist these. Whatever. I'm fine. I like to keep it in a certain order because it's a habit, I guess. You can say, no, I can create my own. Create your own. I write 1, 2, 1, 2, 1, 2. So something like this. 1 times 2 prime equals 1 prime times 2 plus 1 times 2 prime. You want to twist it, twisted it. It's not going to make a difference at all. However, we have to be very careful with the quotient. So this was the product. The quotient, and we'll look at an example in a minute. The quotient rule, f over g, any function over other function, this is a ratio. The denominator has this function prime, squared, only squared, not differentiated. The top is the same rule, but with minus here. So it's f prime g minus f g prime. If you twist these two, then it's wrong. If you twist them in here and here, that's fine. But be careful, don't twist these. If you keep it as 1, 2, 1, 2, I think you're never going to make a mistake. So 1 over 2 is 1 prime times 2 minus 1 times 2 prime over 2 squared. Again, use the method you prefer. So here's an example. 2x minus 1 over 4 minus 3x. And we want to differentiate. I like to start with 4 minus 3x squared, so I don't forget. And then the top, the first function prime. Can anyone give us the first function prime? What does it equal to?
2.
Excellent. Now I have to multiply by the bottom. I reach the minus. I have to copy the top. And times, I have to differentiate the denominator. Can anyone give us the derivative of this?
-3.
-3, and I have to write parentheses. Awesome, thank you. It's good, but it's not good enough. I have to fully simplify it. I will distribute 8 minus 6x. I will distribute, these two will become positive. So now plus 6x and minus 3 over 4 minus 3x everything squared. Do not be tempted. Please do not fall into that trap to do anything with these. So I have minus 3, and again this was positive, so 6x minus 3. These two go away. 8 minus 3 is 5, so the fully simplified form is 5 over this. And this is how we apply the quotient rule.